Good morning in the room, and I hope also multiple people in online. Welcome to this event, KNX event, KNX Radio Frequency Multi S-Mode in action. Today will be a full program. I myself will start with giving an introduction to KNX Radio Frequency and to the novelties being introduced by KNX RF Multi S-Mode. Then my presentation will be followed by a break, so that everybody can sit down and relax and also assimilate what I have told in my presentation. And then will be followed by a presentation from my colleagues Jan Kessler and Michael Critchfield, who will show you KNX radio frequency in action in ETS, so in the ETS6, and will also show how KNX radio frequency multi is handled in ETS6, together with concepts like segment coupler and security proxy. So after that, here physically in Frankfurt, we will have our lunch break, so that will be around 1 o'clock, and we will have a break until about 2 o'clock. And after that, we will have a technical deep dive into KNX radio frequency. So in the room, if there are any manufacturers also intending to have a look at KNX radio frequency for their product development, then this is the place to be, or this is the presentation to be. So this will be brought by Jens Kamenik, and he will really tell you about the bits and bytes of KNX radio frequency multi. After that, this will be followed by a Q&A session. So both the people in the room as well as those online can fire questions at us, which we will try to answer both online as well as in the room. So we should finish by around 3:30, 4 o'clock. To have so those who are online, they can then of course immediately go home, but then to give you a sufficient time to travel. So the next slide in this presentation, which you have already noticed, I think we are also organizing a game today. So our well-known Kahoot games. So after 45 seconds, this QR code should appear on the screen. So if you take a picture of this QR code, then a link should appear where you can participate in a quiz. There are not 100 questions to ask, don't worry. It's less than 10. So both here in the room as well as in online, here the QR code appears. So until 1 o'clock, so until the lunch break, you can participate in this game, and you can win 3 sets or 3 sets of KNX radio frequency S-Mode multi devices can be won from the company ISE. It's an USB interface, it's an TP RF media coupler, and a multi-thermostat battery driven. These products will be available from September onwards. So please participate in the game, and then we will draw 3 lucky winners in the room and online. So without further ado, I would suggest that we start with my intro to KNX RF and the evolution it has seen in the last years. I will try to give you an introduction to KNX radio frequency. because KNX radio frequency has made a long journey to be where it is today. So KNX radio frequency is not new. KNX radio frequency has been about for about 20 years. But it has seen a lot of evolutions since then. And I will guide you a little bit through this journey. So I will give you an idea of what the original requirements were when designing the KNX radio frequency system back in the noughties, the beginning of the noughties, 2004, 2003 about. Then I will give you an overview of what the original features were of the original KNX radio frequency easy mode. And I stress a little bit easy mode because at the time of designing KNX radio frequency, the objective was to configure these devices without the help of the ETS tool. Then we moved towards KNX radio frequency ready easy mode. Sounds a little bit the same, but there's one extra word, which is ready. I will explain what that means. Then KNX moved towards KNX radio frequency multi easy mode, and I again stress the word easy. And then we moved towards also being able to handle KNX radio frequency products in the ETS. That's why we moved towards KNX radio frequency ready and multi S mode. So in the ETS, then at that time, it was possible to, as a KNX installer, also integrate products in an ETS project. And one of the novelties which is presented here and on which we have worked several years is that we wanted to also improve KNX radio frequency slow, low energy. Now we wanted to introduce a possibility to have an extension to radio frequency that would not deplete batteries so easily. I'll explain you how this was done. Maybe you also heard that KNX is working on the KNX IoT project. There's also wireless communication foreseen there. What is the difference to KNX radio frequency multi? I will also explain you briefly that difference. And I will also, at the end of the ride, I will show you a table in which I will compare KNX radio frequency multi to other solutions like KNX IoT thread-based or Matter thread-based or Bluetooth mesh. And I will make a bit of publicity at the end of the ride for products that will see the light in the coming months, all based on the KNX radio frequency multi-S mode technology. Okay, what were the original design requirements when the KNX manufacturers wanted to extend the original twisted pair system with a wireless solution? First, they really focused the retrofit market. So an existing installation that could be extended with KNX through wireless solutions. The idea was, the focus was home and residential market. Again, KNX is a decentralized system. Again, the wireless extension should also be decentralized, but of course, centralized functions like a display should be possible. They wanted to have the possibility to develop standalone solutions, but also be able to couple this wireless solution also to existing TP-based installations. And it should be possible to implement it on off-the-shelf components. So meaning there should not be a very, very specific microcontroller that should be exclusively used for KNX radio frequency, common radio frequency components should be usable also for this solution. And of course, small footprint, this is evident. And for smaller installations, it should not be required to have retransmitters. So a small installation should be able to cope without having retransmitters. And at that time, now it is not so important anymore, but at that time, there was absolutely a need to be able to also implement unidirectional devices, meaning devices that simply only send out a message, but are unable to listen to the bus. Low power consumption was already then the focus, and this solution should be fit for all typical KNX applications like heating, ventilation, air conditioning, lighting, sun shading, etc. The domains we know pretty well from KNX. And also a focus then also has become less important these days, but was that one should be able to easily couple the radio frequency world, the KNX radio frequency world, to radio frequency used for metering purposes. At best, the same chips should be able to be used for both applications. And like I said, the focus was on, we don't want configuration with the ETS. We want to be able to use easy configuration mechanisms, so plug, touch, and play mechanisms to link devices. Okay, important was that the design should be based on international standards. So this should not be a KNX specific solution. It should be a thing that is KNX, again, part of the bigger KNX standardization work. As you know, KNX is standardized in Europe as EN50 so the radio frequency solution should be from layer 3 up to layer 7 of the OSI layer model. It should be part of the 5090 series. And layer 1 and 2, so the physical layer and the data link layer, should be also become part of this 5090 series. So when you look at 5090-5-3, you're looking at the KNX radio frequency solution. And this solution, as I said, should be common to the solution that is also used by MBUS. So the technical committee that is dealing with MBUS is the TC294, the CEN TC294 committee. There should be the physical and the link layer should be aligned as much as possible. And the radio frequency should be in accordance to this regulation. It should be situated in the 868 megahertz band. So deliberately not in the 2.4 gigahertz band. And the link layer format should be in accordance to an IEC standard, the so-called FT3 protocol. If we look at the original design of the KNX radio frequency physical layer, then the frequency that is used is situated in the so-called short-range device band, and the frequencies that is used is between 868.0 and 868.6, and the transmission power is limited to 25 milliwatts, with a duty cycle which should be less than 1%. I'll come back to that later. Okay, if we look a little bit on the requirements and the characteristics of the KNX radio frequency physical layer, this is a snapshot from the KNX specifications of the original KNX radio frequency physical layer. I will explain a couple of interesting features that you should know when looking at KNX radio frequency. So, As I have said, the frequency band is 868 till 868.6 with a 1% duty cycle. That means that a device may, per hour, transmit a maximum of 36 seconds, not more. The center frequency being 868.3 megahertz. The modulation technique that was selected for KNX radio frequency is the frequency shift keying mechanism, and I'll briefly explain what that means to you, or what that means. So if you look at the upper part of the picture, if you have the information signal, and you have a carrier, in the third line, you see what an amplitude shift keying would look like. And in the lower line, you see what the technology that is used for KNX radio frequency. So the frequency shift keying. So the logic states 0 and 1 are generated by a slight deviation in the carrier middle frequency. The RX sensitivity, so how sensitive should a device be to the reception of wireless signals? So this is typically minus 95 dBm, so that is pretty low. And the minimum is minus 80 dBm. So that means that devices that are apart should be able to still receive this kind of signal strength. Also very specific is the bit coding. The bit coding is Manchester coded. This is explained what that means. So a bit 0 is coded as a frequency high to frequency low transition, and of course the bit 1 is the reverse. The bit rate is at 16.384 kilobits per second, and here you have the rest of the table with a number of other features. So the actual frame is preceded by a preamble of 30 chips, and there is a so-called Manchester violation that is inserted for capture effect, and a sync word that is used for synchronization, as the word says. Also, I have already touched upon that. The data link layer format is in accordance with ISC, and we also have a CRC check on the different blocks inside the telegrams. I will explain you that in the next slides. Also important is that KNX radio frequency checks whether radio transmission is already ongoing before starting an own transmission, so as to avoid, of course, the number of possible collisions. I promised you that we would look briefly on the KNX radio frequency telegram structure. So this is the general structure, so in accordance with this FT3 standard. So you see, we start with a preamble. We have a first block with its corresponding CRC. We have a second block with the corresponding CRC and further blocks with their corresponding CRC, and then a postamble. So the preamble, as I have already mentioned, has this Manchester violation and this sync word. And the first block consists only of 10 bytes, where the further blocks are 16 bytes long. And the last block could be 1 to 16 bytes. The postamble is only 2 to 8 chips long. Okay, if we look more deeply into the first block, the first block has some specific values. So the C field is always set to 44 hex, so it's a fixed value. The escape code is an escape code to separate KNX from metering. You remember, KNX was designed to be able to use the same chips as radio frequency metering. And the control byte indicates whether this telegram is being sent by a unidirectional device or by a bidirectional device. It also indicates how good the signal strength is, and it also gives an indication on the battery state of the device. The next 6 bytes is a very important element in the frame structure. It's the serial number. The serial number indicates either the serial number of the device, but in future extensions, also very important, it indicates the domain address. The domain address is very important to be able to separate a KNX radio frequency installation from another KNX radio frequency installation. So if you have installed a radio frequency system in your home, you don't want it interfered by a radio frequency system that is installed by your neighbor and vice versa. So this domain address plays an important role in that. The next block, so the second block, indicates whether, so the first byte indicates whether this uses the standard format or the extended frame format. KNX radio frequency uses only the extended frame format. And then also in the standard frame are elements that indicate elements like the LFN. So the LFN is used to, it's a telegram number which is being sent along with each telegram. So to avoid or to allow receivers to see whether they have already received this frame or not. So to avoid duplication. And then the last is the data. Important to know is that of course, you have very specific radio frequency elements that are added to that. But when you see the actual data that is being sent on radio frequency, this resembles very much what is being sent on twisted pair. I've indicated that the original design of the radio frequency wanted to be able to communicate without the use of retransmitters or repeaters. But in the case where you have an installation which is a bit bigger, then up to 3 retransmitters could be inserted in a KNX radio frequency installation. And in the frame is this link layer frame number, so the LFN. So in the case where a receiver receives a telegram and on the basis of the LFN, it establishes that it has already received this frame, it can ignore it. And also the routing counter, which you also know from twisted pair, is equal or lower than 5, the retransmitter will no longer will not retransmit the received frame again. At the time when the design was made for the first radio frequency easy mode, people wanted explicit unidirectional devices. And because of the need to have unidirectional devices, and they did not have the possibility to change group addresses in the devices. So most devices used standard, so fixed group addresses. one needed a mechanism to be able to distinguish on the receiver side one group address from another, because the group address was fixed. So another element needed to be added to that to distinguish that this group address was being sent by device A and not device B. So what they did, they padded the serial number, or they used the serial number of the sending device to be able to distinguish one group address from another. This had, of course, serious consequences, and this was an element that could not be reused for KNX radio frequency S mode. This needed to be changed, but I'll come to that in a minute. Okay, so this was the original design of KNX radio frequency. So we are going to move one level up. We are going to now talk about KNX radio frequency ready. So what was the change between the original design and KNX radio frequency ready? It was still a single channel. So you only had one channel, this 868 till 868.6. But we moved towards a preamble which was longer. Why did we want a longer preamble? Because we were already designing the KNX radio frequency multi solution. We were already thinking of extending the single channel solution to actually 5 possible channels. And that's why to allow the multi to hop from one channel to another, this preamble needed to be longer. There were some bits that could be ignored in the control field on the receiving, when receiving, but the rest of the stack was absolutely identical, and manufacturers could simply upgrade their products via a simple stack or software upgrade. From that moment onwards, it was not allowed anymore as manufacturers of radio frequency to still design KNX radio frequency as it originally was designed. So it was a must to implement KNX radio frequency ready. But important also, KNX radio frequency ready could not send acknowledgements. So if a sender sends a frame, there was no possibility for the receiver to actually confirm this message. So as you know that from Twisted Pair, Twisted Pair confirms the reception of frames. So there is no possibility to actually have a confirmation that the telegram reached destination. So that was, I already mentioned, a lot of the reasons why the next evolution was towards KNX radio frequency multi. One reason was if one channel is blocked, one wanted to have the possibility to be able to, as a sender, to hop to another channel, which was then hopefully free. So as you see on the picture below, there introduced were 2 fast channels. So the original channel, which is equivalent to the radio frequency ready solution, a second fast channel, a slow channel, and a fast channel or another slow channel which uses the same frequency band. Already at the time when multi was introduced, already one looked at the possibility to reduce energy. That's why they introduced the so-called slow channels. So the idea was in a slow channel, a device can sleep for a certain time and needs to wake up from time to time to listen whether there are any messages intended for it on the bus, in order to be able to save especially battery power. But I will come to that also this solution still had drawbacks, which were later on remedied with radio frequency multi S-mode SLE, but I will explain that in a minute. Also very important, so the multi solution introduced for the first time a concept of a fast ACK. So the possibility for receivers to confirm the reception of messages. So the fast ACK is, however, limited to 64 individual receivers. So these individual receivers all have a possibility, they have a slot where they can confirm the reception of their specific frame. So important to remember is that contrary to twisted pair, there is a limitation. And you will also hear from our colleagues that ETS will, of course, ensure that you will not link more than 64 individual receivers to one sender. So if this ACK is missing in the specific slot, the sender will repeat its message. Also very important, by introducing KNX radio frequency multi, there was an obligation for manufacturers, if they have multi devices, to be able to downgrade the products to ready. So if you have a ready only solution and you want to add a multi device to it, then via manufacturer specific means, you can downgrade the product to become ready. Okay, so I have drawn here a table, which some of you, if they are dealing with KNX training, they may recognize. This is part of the KNX radio frequency chapter in the standardized course material. So if we look at the different product types that could exist in a radio frequency system, if we look at transmitting devices, then actually in KNX radio frequency multi, transmitting devices should be able to handle both ready messages as well as or be able to send ready messages, multi fast messages, so and as well as slow messages. On the receiving side, if they are mains powered, so if you have, for instance, a relay switch, then such devices shall at least be able to receive ready messages as well as fast messages. If you have actually a battery-powered actuator, so if you have a heating valve, for instance, a heating or cooling valve, then on the receiving side, it is allowed that these only support slow channels in order to be able to save energy on the battery they use. And if you have, for instance, a mains-powered controller, then also because they are mains powered, they should be able to handle ready as well as fast. Important to know is that if you have a slow sending or a slow receiver, then the slow receiver, when you put it into programming mode, this should also be able to handle fast messages. So during a download by ETS, the device will also allow to receive fast messages. In the case where you have a ready device wanting to reach a slow device in the installation, the media coupler will actually help that the ready message is converted into a slow message to reach the slow receiver. And for KNX Radio Frequency Multi, we fixed that a maximum of 2 retransmitters can be placed in an installation. This can be a specific device, but this can also be part of the media coupler functionality. Okay, here I have again depicted the overview of the different preambles. So the part preceding the actual frame. So in case of a ready device that only sends in the first channel, the preamble is only 5 milliseconds preceding the payload, and this ready device does not send, or the receiver does not send acknowledgements. In case of a fast device, the preamble has grown to 15 milliseconds, but it has the possibility to send fast X. And in case of a slow device, the slow device has a preamble of 500 milliseconds and is also able to send X. Below there is a picture showing how this ACK confirmation is inserted into the frame. Okay, so we we had the original design, then we had radio frequency ready, easy mode. We had radio frequency multi, easy mode. And now the manufacturers decided at one point in time to extend radio frequency also to be configurable by the ETS. So a number of application notes were drawn up, which lay down how the KNX radio frequency, the original version, should be extended to be manageable by the ETS. The main difference between the easy mode and the S mode lies in the use of the domain address in messages, separating your neighbor's installation from your own installation. And the individual address, of course, and the group addresses, they are commissioned into the device by the ETS, as you know that from Twisted Pair. And also very important, when as a manufacturer you make a radio frequency multi-device, it must support KNX Secure. Okay, now this slide is a bit full actually, but it explains the reason for introducing the multi-RF S mode slow low energy extension. This is a big mouthful, but the slide shows that there were really reasons to introduce this, because we established that the original development had too much time, or there was too much time foreseen for the devices to hop from one channel to another. And modern electronics allow to do this much faster than was originally designed. So that's why the SLE, so I'll abbreviate it to spend less time. So the newer electronics allowed to have that much shorter. In this way, saving time and saving especially battery. In the case where a slow receiver received a frame that it thought it would be intended for it, then it stayed too long in this receiving mode. There was no way of, during the preamble, to identify, am I being addressed or not? If the preamble was recognized, then the device had to stay awake And maybe during the frame, it established, this is not my group address, or worse, this is not my domain address. So it wasted energy for possibly nothing. So a more intelligent solution had to be found to already in the preamble already find out, am I being addressed or am I not being addressed? And the more slow devices were included in the installation, the worse this power consumption was. That was also established by the manufacturers. So what was the solution? The scanning and hopping was shortened by 1/6 of the original value, so from 6 milliseconds to 1 millisecond. The data rate was also increased to the level of fast, and the preamble was made smart. So in the preamble, the domain address was, or part of the domain address was included. And also the destination address was the type as well as the group and the individual was included in the preamble. So during the preamble, the device can already say, okay, I look at the first part of the domain address. This is not equivalent to mine, so I can go back to sleep. Or this appears not to be my group address, so I can go back to sleep. So the result is that if there is no KNX frame on the medium, so if it's detected that it is not a KNX frame on the medium, then after 18 bytes, the device can already go back to sleep. If for neighboring KNX installations, so if I detect another domain address, I can also go back to sleep after 18 bytes. If the own installation is addressed, so if I'm detecting my own domain address, I can sleep until the preamble block just before the frame starts. So I can even then go back to sleep. And if I'm not addressed, then I can sleep until the current telegram has been transmitted and start the next telegram reception after that. So this results in considerable energy savings, and so the battery in the device will last much longer. So thanks to these extensions, neighboring communication has practically no influence on the power consumption. Consumption in another room has a minimal influence on the power consumption. And the more foreign devices there are, other rooms or neighboring, the better the gain. Okay, so nearly at the end of the presentation. So as you may know, of course, KNX has worked not only on KNX radio frequency multi SLE, but it's also working on the KNX IoT extension. So we have our lovely twisted pair, we have our lovely radio frequency, we have KNX Net IP, KNX Net IP IPv4. Everything is secured via data secure or IP secure. And the idea is that to be able to extend the IP network with an IPv6 solution. So KNX Net IP was limited to IPv4. The idea of IoT is to extend it with an IPv6 section. This can communicate wirelessly, or this can also communicate wireless, like on single pair Ethernet. But the idea of when selecting for the wireless option, the idea is to go for communication based on Thread. Thread is an IPv6 compatible wireless mesh networking solution. And if one wishes to communicate between this KNX sending messages on Thread and the traditional KNX installation, I would call it, then you will need a KNX IoT router. This KNX IoT router functionality could be combined in one single device that also allows KNX Net IP communication. So the traditional IP router or IP interface could be extended with a KNX IoT IPv6 gateway functionality. So if it's difficult to compare one solution to another, so I promised you that I would look briefly into how good is KNX radio frequency multi, how good is or will be KNX IoT on thread, looking also maybe at the competition, Matter on thread, and Bluetooth mesh. So maybe it's still a little bit early to compare also these solutions, because we must be honest, KNX IoT on thread is being implemented as we speak. So the devices will probably see the light now and in the near future. And also the ETS still needs to be extended to also be able to configure these devices. So there is not a lot of experience yet with this particular solution. But and also Bluetooth mesh is well established, but not very common in our particular domain. So, well, the big difference, of course, lies in the frequency that is being used. So we use 868 and 2.4 gigahertz. Physically already, this allows us a larger range than 2.4 gigahertz. The drawback of 868 megahertz is the fact that it may be regionally limited, and you may not be able to use it as a manufacturer on another market than, for instance, Europe. One also big difference between for instance, solutions like Bluetooth and Matter, for instance, in the case of KNX, you as a manufacturer especially, you have the possibility to exert influence in the KNX association, because actually our manufacturers, they lay down these solutions. It's not us in Brussels. In bigger organization like CSA for Matter and Bluetooth, you will probably not be able to exert that much influence. From a development cost of the KNX radio frequency multi might be a little bit more expensive per node than the other solutions. So I'll leave you to look at this slide because I have already exceeded my time. So the last bit is the sales pitch. So to actually demonstrate that this thing is real and not some theoretical thing that KNX has with its manufacturers worked upon, but that this will be a real extension that as KNX integrator you will be able to use in KNX installations. A number of products that will be soon on the market. This first product I'm showing here is a KNX radio frequency multi security and automation window handle. Also a mouthful, but a window handle that will be able to send multi messages from the company BSS from Germany. The second bunch of products will be those that you can win when you participate in the Kahoot game. So it's the RFTP media coupler, it's the battery-powered valve, and the RF multi interface from the company ISE. And also the company Gira will be offering KNX radio frequency multi devices in the near future. So that's it from my side. I hope this was a not too lengthy introduction in KNX radio frequency. And after the break, my colleagues Michael and Jan will demonstrate you how all of that works inside the ETS. Thank you very much for your attention, and see you at some other event. Thanks.
We will show you today here in the room, but also online, an existing installation that has just been extended with another or with an RF line to prove the existing interoperability. We will then add a new product, an RF Multi push button to that installation, to that existing installation, and by that showcasing the maintenance of interoperability. Thirdly, we will introduce a segment coupler, RF Multi segment coupler, and will therefore be showing a new kind of topology, an RF segment. Then, now that we have an RF segment, we will introduce an RF Multi actuator that will then introduce the topic of runtime encryption. KNX Secure comes to mind. Then also, we will showcase the security proxy that will then show us that ETS is maintaining automatic translation tables. And lastly, hopefully we can get to that in the short time that we have, we will integrate a RF Multi SLE device, a heating valve, and through that, again, showcasing the maintenance of interoperability. This is us. My colleague Jan from the company ISE, the ETS PO, today will be act as a product supporter who I will be calling in my acting as an installer. For that purpose, I now put on an installer's jacket.
And I'm the IT guy. So I put these headphones on and the mic. I hope it's working and everybody can hear me.
Can you still hear us? I played a lot with the fabric here, but the microphones are still working. Okay.
So Michael will do most of the stuff in ETS, and I will watch him and tell him what to do and help out in case something will not work. But what should not work? We're working with a development version of ETS and development versions of products, so everything will work fine.
Yeah. Supporting beta products in the beta software. What could go wrong?
Let's go on.
So, like I said, I have an existing family home that the family has contracted me to integrate some RF ready devices. That I have just done. And now I asked Jan to press the buttons because...
But not before you have shown this product, this project in ETS.
Exactly. So here's the ETS demonstration. So what I have here in the family home project, in the building's view, I see an ambient light and a ceiling light in the guest room of the upper floor. And on this push button, we have both lights linked through group addresses. And this works.
So do I understand you correctly that this is our guest room?
This is the guest room.
And you have extended this with radio frequency?
Yeah.
There's a remote control device with which you can control radio frequency lights and lights conventionally connected through twisted pair.
Correct.
Can you show me?
Show you there?
I guess it's hidden behind this paper.
It's hidden. Ah, there it is. Yeah.
So if you push the buttons on the remote control.
So I have the remote control here. It's very small. You might not be able to see it because it's too far away from you. But I have here two buttons. One of them, through KNX RF Ready, pushes the ceiling light on and off, and the other one, the ambient light.
So the blue one is the ambient light.
The ambient light, on and off.
And I'm also able to control this via the twisted pair push button here and there. So the media coupler, the ready media coupler, is translating the twisted pair telegrams to radio frequency back and forth.
Yes, and now that I have introduced this KNX RF Ready device to this project, to this installation, I and also my customer wants to know if this is a future-safe, future-proof investment. So, yeah, we've shown that is...
So when you go back to the slides.
Exactly. I've shown that this works. So I have some findings. In the topology, I have a twisted pair line. And like many of you know, when you add RF ready devices, you end up with at least one RF line. The radio frequency lamp can be switched by a twisted pair push button, but also with an RF ready push button. And also the twisted pair lamp, a lamp on a twisted pair actuator, can be switched by a twisted pair push button and a RF remote control. Now I call Jan because of this question that I and my customer had.
Just basically.
Of the requirement and also the question whether or not this RF Ready addition to my project is secure for the future. Because now we have the idea of adding an RF Multi push button to a project. For that, I again switch to the ETS6.
So you're worried that you have already an installation with KNX RF Ready.
Yes.
Your customer has bought from you, and you now have heard that there are new type of KNX RF devices coming into market, namely KNX RF Multi devices, and what this means for your existing installation. And for this, we will add now one multi device to the existing installation and configure it in ETS.
Yes, we have now upgraded the installation.
So this is the new KNX RF push button device, which supports the KNX RF Multi extensions. And the question is, does it seamlessly integrate into your existing installation? In ETS, you add this device from the online catalog. These are devices still under development, so they are not present in the online catalog. That's why we moved them into a line named online catalog in our installation, and from there we drag and drop it into our project.
From these devices, I choose this device because this is my, in German, Kurzhubtaster, my push button, and I add it to the RF line. Now we go out of the catalog again. Catalog is just an example here because as the product supporter told us, there is no certified devices yet for this in the catalog.
What you might have noticed is that this RF Multi device has the blue security shield. In contrast to RF Ready devices, which could be secure or not, the secure extension is mandatory for the new generation of KNX RF devices. So if you buy KNX RF Multi devices, you can be sure that it also supports security to encrypt the data communication on the air.
Okay. And what I want to do now is link this new device to my installation. So what options do I have?
Just like you did with the radio frequency device, which is KNX RF Ready, with the remote control, link the same functionality to the left rocker. It was the ceiling light on the left and the ambient light on the right.
Ceiling light switching to the left. Ceiling light status as feedback. And the ambient light switching to the right with the status to the right. Okay.
Maybe at this point in time, one word for those installers who are familiar with ETS and look at this ETS version and do not feel familiar anymore. This is the new UX for the ETS version 6.1, which will be released in a few days. There we have in the sidebar the possibility to search for group addresses, which makes it very convenient to link group addresses to group objects inside ETS.
Indeed, yeah, this was indeed really easy.
So this is what you did. What we need to do now is download this device.
I click, so I have the device selected, I'm on the device, I select download, or should I do something else?
Download it, go
Download
on.
is fine, yeah.
So
So
we
I
need to
suppose it will
enable the-
ask me to push
I'll
the
do this for you.
programming button. Yep,
Now it's working.
thank you.
It was my fault. I didn't wait long enough. It's the programming mode of the push button device. Yes. Are you connected
It's
via
wrong,
the,
it's the wrong interface.
RF stick?
Yes, I am.
And
Okay.
what does he said? Download failed?
Yeah, because it was the wrong interface.
Okay, you picked the wrong interface.
As often as you test this in advance, of course. Do we still have the programming mode activated?
Yes, it's still blinking.
Okay, good. Now it's working.
Yeah, we're a little bit working on the open heart of ETS with 3 interfaces at once, something that you typically do not do at home.
Hopefully.
Yeah, hopefully. You have to take special care to select the right interfaces, right?
While this is downloading, what additional functionality do I have now when this is finished?
When you integrate a multi-device into an installation that is configured as RF ready installation, the multi-device falls back to ready mode during runtime. So while it's working, sending out group addresses and frames on RF, it's acting as a ready device. The only addition that you have is the enabled security for the protection against configuration. So the download of the device is done with secure telegrams, and afterwards the device is locked. So without ETS knowing the keys to access the device, you cannot reprogram this device.
Okay, so I integrated a new RF Multi capable device, and without anything else, it is compatible with what I have.
Yes,
Simply
you didn't have
switching-
to know that this was an RF multi device.
Yeah.
You added it like the other device, and I hope that it's also working like the other device. So you can here switch on and off the ceiling light and the ambient light. So although this is a new generation of device, it seamlessly integrates into your existing installation in case you already have ready devices.
Okay, this is great.
So much for the summary.
So we have some findings. The RF lamp that we have, the ambient light, and the twisted pair lamp, the ceiling light, can both be switched by this new RF multi push button. During that operation, the RF multi device that we added is acting simply like an RF ready device. And the download that we did, that has happened protected using KNX secure download. Okay, now we will add an RF multi-coupler, because I hear this will bring me additional benefits to the installation. We'll do that, and then we will talk about what.
Yes, so far it was nice that this new type of device integrates into your existing installation, but for sure at some point in time you want to make use of these additional features that RF Multi brings. For example, the acknowledgement of the telegrams, the multi-channels, and the encryption of the communication between the devices. In order to do this, the multi-device, we have a push button here, needs a communication partner. And the first and natural communication partner of RF devices is the media coupler, which does all the translation between radio frequency and twisted pair. So let's exchange the media coupler and see what additional features this new media coupler has. So first of all, I'm disconnecting this one.
Yeah, the old one out, then the new one in.
Okay, you see that this existing media coupler is connected to a dedicated line that needs to be connected to the twisted pair through a main line. And one thing that makes it a lot easier to work with RF media couplers is the functionality of segment couplers. So that you can now, inside a twisted pair line, have a segment for all of your radio frequency devices. And you can do this by simply dragging and dropping a media coupler into the twisted pair line, as you do with all of the other devices in that line. And let's see what's happening then.
So here's this new coupler in the online catalog, and I simply, like you told me, add it to the twisted pair line. And I see now there's a new RF segment. So you mean to tell me that I can simply put this in a twisted pair line? I don't have to have it as an additional line?
You do not manually have to create an additional line. You also do not manually have to create the segment. ETS automatically handles this and creates it for you. Wherever you add a media coupler or RF coupler into a twisted pair line, ETS today's, with the old version, says this doesn't make sense. It's a twisted pair line. The new version says, okay, obviously you want to have a segment of this line being radio frequency. It creates the radio frequency segment and adds the media coupler into this segment automatically. And also it needs to be physically connected. So I added here, got power, okay.
Okay, so now I have this segment.
Yeah, let's move some of the devices into that segment to see the difference in the topology from the old line approach to the new segment approach.
Okay. Which devices should I move to the segment?
Let's take the remote control device, the
So I simply drag it from the RF line directly into the segment.
Yeah, and
I see the address has changed.
Device. This multi-device, because we want to start seeing more multi-functionality.
Okay. So now, of course, the addresses have changed, the individual addresses of these devices, because they're not in a line anymore.
That's right. Yeah. But first, delete the old line so it doesn't interfere.
Okay. Now I have the segment.
Yes, and now we're doing some hardcore magic. Change the domain address to the well-known domain address we have prepared for this presentation, just to be sure that the communication still
the domain of the segment
works for those devices which we are not completely reprogramming.
Okay.
So all that's now wrong are the individual addresses, and for this we need to reprogram the devices.
Okay. So the domain address, why did I change this to this? Because not everyone knows his domain address or knows a domain address.
The domain address separates RF lines and RF segments from each other. So if you have a large installation, it might be favorable to have multiple media couplers spawning up their own individual domain with different domain addresses, instead of having only one media coupler and trying to use a repeater to reach the other devices. Very similar to Wi-Fi, where it's better to have multiple access points instead of having one access points and repeaters.
Okay.
And for this, the domain address separates these different RF lines and segments, and we move the devices from the former line into this new segment. And just to minimize possible things which could go wrong, we make sure that in this new segment we use the same domain address that we formerly used in the line.
Okay, so
Just
for
this
separation purposes.
presentation purposes, normally you should not care about the domain address.
Okay.
The domain address Michael put in was randomly?
No, it's exactly the same that we had on the
Before.
ready 1.2 line, just to be sure that
Normally I understand ETS would take care of the domain
ETS
address.
takes care
It's-
of these details. Yeah.
creates
It's
it.
just for this
Yeah.
presentation
For
purposes.
this demo, okay, understand.
But still, the individual addresses have changed. They had a 1.2 address from the line. Now they're inside a segment of the 1.1 line. So the individual addresses still need to be programmed.
Like ETS tells me here as well.
So please go on and select these devices.
Should I do the media coupler first?
It's always a good idea to program the coupler first. I guess most of you know. Maybe in the future ETS supports in this. But yes, please download the coupler first.
Download completely, or should I start with the individual address?
Just let ETS decide what
ETS
to do
does
and
it for me.
start the download.
Okay, so I need to.
I will need a programming device.
You need a programming device. Yeah. I need to change my individual address of the interface.
Yes, for sure. Not only the individual address of the devices have changed, also the interface, which was playing in the old 1.2 line, now needs to be part of the 1.1 segment. But this is, ETS told you that this is no longer matching and gave you the possibility to correct this interface settings.
Yeah. Okay, so now the media coupler is being programmed. The flag for the address is already there, I can see. And I guess after the download, it does a restart. And then I simply go on with the next device.
Maybe just change one little thing. We see that the media coupler doesn't have security activated at the moment.
Okay.
But in order to see the full potential of the media coupler, please activate the security and download it again.
I do this here in the properties, right?
Yes.
So I
The secure
activate.
commissioning, yes. If you activate it, we have scanned the FDSK up front, so ETS knows already. And if you now re-download this, simply press download, then ETS activates the security on this device, and this enables the full power of the KNX RF Multi segment.
So when it can and when it finds the compatible devices, it will communicate securely.
Yeah, we will see later on that ETS automatically enables or disables security on certain group addresses. Whenever it's possible to communicate securely, ETS will enable it automatically in the background. And whenever this is not, because there's a link to a legacy device, for example, the security will automatically be disabled. So you do not have to take care on your own to enable in security in all of the places. ETS does its best. Whatever is possible will be activated automatically.
Very nice. Okay. Should I now program also the remote control?
Yes, do these devices one after each other. And then we will see a difference in the group monitor compared to the installation that we had previously with the old media coupler in a line compared to the new media coupler as a segment.
So I had to activate the programming button on this device.
Yeah, it's a unidirectional device. So if you want to program it, contact it, you have to wake it up manually. The new multi-battery driven devices, there are listening with this multi-SLE, so battery friendly, but still all the time listening. So you can wake them up via ETS. Do not have to do this manually.
Okay. I'm also programming the push button now, the RF push button. So it also asks me to press the programming button.
So you asked me to press the programming button.
Please ask you.
And I have learned to be patient enough. Okay, now it's blinking again.
So what do we do next? Is it best to switch to diagnostics now to see the effect of what we just did, or?
Yes, I guess if we look through the group monitor of what's happening on the air, we can see the difference of the old legacy media coupler compared to the new media coupler in conjunction with the new multi-devices.
Okay, so I switch to diagnostics now that the programming is done. I'll start the group monitor.
Yeah, be sure to select the RF part because we want to monitor what's happening on the air.
Okay, I see it's running. And
Perfect.
also I see you pushed the ambient, you turned the ambient light off.
Yeah, can you do this via the remote control?
I
That
can
you
also
just
do this here.
reprogrammed? On and off, toggle it back and forth. Yes.
So I turned it on with one group address, and I see 3 group addresses for the off, basically. Why is that? Why do I see 3 group addresses? 3 telegrams for the off.
The ready frames are not acknowledged. That's why some devices repeat the ready frames on the air. So you might see them multiple times just to ensure that they have really reached all of the recipients, because there is no acknowledge on radio frequency with ready mode. But this is still ready communication. And the same would happen if we would use the multi-device to do this. So if we here enable and switch on and off the light, we see this. The difference is when now ETS configured the multi-device to communicate with the multi-coupler. And this happens when you communicate with the devices on the twisted pair, where the frame goes through the coupler to twisted pair. So if I enable, disable, activate and deactivate the ceiling light, we see a small difference here. And this is, you have to look very closely. Maybe you can use your mouse pointer so also the online audience sees this.
Indeed, I can see there's only one, so 2 telegrams here for the ceiling light.
Yes, and there's a small difference in the frames, which is most obviously, if you look at the hop count. Joost already said in his presentation that for multi-communication, we have a maximum of 2 repeaters. So the frames start with a hop count of 2 there. So you can identify this was a multi-frame.
Okay.
This means that for the communication of the switch actuator back to the push button device to see the status LED, this communication between the media coupler and the push button device happens in multi. So it's acknowledged, the media coupler ensures that it's really received by the device, otherwise it would be repeated and so on.
Okay. So I see this on the hop count of 2, whereas up here, when I switched the ambient light, we always had the hop count 6. And now on multi, we see here the hop count 2.
You have this radio, this ready device, the remote control.
Yes.
And this is also linked to the switch group address, so to the control address. Therefore, the device sends the control message via ready. So that is also received by other ready devices which are linked. But the status is only sent back to this device which has a status LED. Your remote control doesn't, so it's not linked to the status address. So the status address is only linked to multi-devices. So ETS automatically configured this. Okay, the switch control needs to be ready because of other devices listening to it, but the status feedback can be multi. So ETS automatically configures all of the communication tables of the devices and the media coupler to be as good as possible. Similar to security, when multi-communication is possible, it will be activated automatically. If not, ETS will use the fallback mechanism with ready.
Okay, so where it can, ETS takes care of this for me. This is good. Do I still have a light on? Yes, now I do. Okay. Great. So
far,
what else can I do?
Summary of this extension that we did, we changed the RF line to become a segment.
So ETS created the RF segment for me. I do have, maybe as you noticed, and especially as I noticed, I have a lot more flexible options for placing the media coupler and a much easier topology, because now, as I realized, I can put this new media coupler anywhere on my line. I don't have to put it as I don't have to place it as a main line.
Yeah, the main line might be in the cabinet where
Yeah,
you then connect the media coupler to connect to the main line. Whereas the line 1.1 going through your home, the green cable is everywhere. So you can pick the best location for the media coupler in terms of radio frequency reception range, the best location where on this green cable you put the media coupler. If you open a segment, it can be opened physically on any part of the green cable where the crystal pair line goes along.
I think this is the greatest benefit already, because this helps me a lot, especially in this family home, where I will already get the requests from the family to place more devices. What else can I do? So now we will be extending this installation with an RF Multi actuator.
Yeah, so far we have seen communication where multi-devices and ready devices are mixed. The full potential of multi can only be seen if we have pure multi-communication. And for this, we add a new actuator device, which is also multi, to see the pure multi-communication between the multi-push button and the multi-device. So we have here another multi-device.
I brought this to the family home already.
Is there enough space?
Yeah.
Okay.
Okay, so what does this do?
Let's say this will be our desk lamp, and the actuator channel 1 will, this one here will be our desk lamp, and we replace the right rocker of our push button device to control the desk lamp now.
Okay. Do I find this device also in our catalog?
Go on.
Very cool. And I can place this also in the segment.
Yeah, directly place it in the segment. It will have security activated as it's a KNX RF Multi device, so for the protection of the commissioning. But also what we want to see now is that the runtime communication. So we need new group addresses on the push button and also the same group addresses on the actuator. Group addresses you in the new UX of ETS 6.1 you will find in the sidebar conveniently. And
oh, here's the desk light.
Yes, use this one.
How convenient. So I switch to my actuator, and you would say to put this best on the right rocker.
This is the actuator to choose any of the output channels.
Oh,
so either 1 or 2, it doesn't matter. It's either the left lamp or the right lamp.
Okay. Good. Where else do I need to link this group address?
We want to control it from the multi push button device. So directly above the actuator, you see the 2-fold push button device, the 1113.
1113.
This was currently controlling on the right rocker the ambient light, which we no longer have in this part of the demonstration. So remove the right rocker group addresses and replace them with the new desk light. It might be very small, but you can already see in the group address list that these group addresses we are now using have the blue shield for security.
Desk light status. Yes, I also see it here in the list.
Yes, also the feedback has this, right.
So the status I can also see here on the right-hand side.
Exactly.
Very nice.
So when you now go on and program these 2 devices.
Should I also program the media coupler again?
We don't need to do this right now, but
okay, I'll start with the actuator.
Yeah, this is the new device. You see also the programming flags for address. It's not set yet, so
so on this
needs to be
actuator,
completely programmed.
The programming
activating
button.
the programming mode again.
Okay. But generally, when ETS suggests to program a device, especially when the group configuration is missing and the configuration, I should follow that suggestion.
Yeah, especially for the coupler.
Yeah.
And we will see later on one example where configuration on one device has effect on many other devices. We will explain why and why it's good to follow the suggestion of ETS to then really program all of the devices.
I generally always like when I see green flags everywhere here. So
Everybody likes green flags,
Indeed.
especially in the reports when the project is finished.
yeah. This is also always what my customers want to see.
Yes, so completely programming this new actuator device took some time. Now we only need to do this again for the push button.
This should go now a little bit quicker.
Yeah, the group addresses of the right rocker have changed, so
but nothing else.
not a lot. Yeah.
And I'm programming still over the RF interface.
Yes. You could also do this from twisted pair,
Okay.
but as we have the need to see this in diagnostics, what's happening on the air, we're using these USB sticks.
Okay.
So it's always favorable to go directly into the line where you program something and not do this over the coupler. And for radio frequency, it's easy. You don't have to go somewhere in your building to connect to the correct line. You just plug in your USB stick and connect to the correct segment over the air.
Indeed. So now I programmed the push button and the actuator. I will also program the media coupler. Or should I not do that yet?
Not necessary in this step. We only did the connection between the two radio frequency devices.
Okay.
But if you go to diagnostics now.
And I don't have to do that yet because they communicate directly.
Yes.
Okay,
the difference we see now is that if I use the left rocker, which controls the light in twisted pair, we will see again the communication which is ready and multi unencrypted. But if I use the right rocker, we see this encrypted communication between the two radio frequency multi devices. So
and there's only one so yeah, there's no repetition. And like I learned, this is because of the acknowledgement.
Yes, the push button sending out the control frame received the fast acknowledge from the actuator. And this is currently configured as the only device which wants to know about this telegram. So in this case, the push button is sure that all of the devices who are interested in this telegram have correctly received it.
Okay.
And the other way around, that the actuator for the status LED sends the status telegram, is then also confirmed with RF Multi fast acts.
Very nice. Okay. So, what did we see? We saw that these group addresses that we added for this new actuator, RF Multi actuator, they are now encrypted. And these RF Multi devices, the push button and the actuator, they communicate directly in RF fast, with also serving an acknowledgement. And that's why we don't have a repetition. One status, so one telegram was enough. What can we do now on this project?
You said that you liked green flags.
Indeed.
Me as a security guy, I like secured telegrams. And as we have seen, the control of the ceiling light on radio frequency is still unencrypted. So what we need to do now is to do two things. If you open up ETS again.
Should I go to the buildings tab or should I stay in topology?
Go to topology because we need to do some configurations on radio frequency devices. we have learned that one of the reasons why the control frame from the push button to control the ceiling light was sent in ready and unencrypted was the connection to your remote control device. So if we remove this now,
Should I remove the device or just the linking? Just the linking because we will keep this device.
yeah, just remove the group addresses
Yeah.
For the ceiling light from the ready frame.
Okay, so now I don't have any group addresses assigned to this device.
Exactly. So if you now open the push button, the 1113, you can see that also the objects for controlling the ceiling light have now this blue security shield. So what ETS will do is to encrypt these group addresses.
Simply because I removed the device that used
Yes,
them.
so
that was not-
inside the RF segment, there's no legacy device anymore
Yeah.
that doesn't support security. So this can be sent securely. You might ask yourself, how can this be? Because the actuator still is a twisted pair device not supporting security.
Indeed.
And here comes in another functionality of the new media coupler that ensures that on the way over the air, everything is encrypted. And if it needs to be decrypted again for the communication on twisted pair, this will be done by this media coupler. So let's go on, program the media coupler and reprogram the push button.
Programming the media coupler.
Yes, this is the security proxy functionality of the coupler.
I will also program the push button.
So from
And
a security standpoint, it's okay, the green cable inside the concrete wall of my house, but the communication which is happening over the air can easily be watched and controlled if it's not encrypted via a USB stick from somebody sitting in a car located in front of my house. So I especially want to have all of the radio frequency communication being encrypted. And if this is not possible for the communication on the twisted pair wire, we have the new media coupler taking control that at least the part of the communication over the air is encrypted, and then he decrypts this on behalf of the sending device for the remaining communication length to the actuator. We will also see this now.
Only with that future product.
This new media coupler, exactly.
Yeah, my customer will be very glad to hear this, that I can secure the RF transmission.
Exactly. As security questions are coming up more and more, you now have the right answer to all of these questions. If we open diagnostics, you would see now, after everything is programmed correctly, that not only the communication to the multi-actuator is secured, but also the radio frequency communication to the, I'm not sure if everybody saw this, to the twisted pair actuator. You can maybe open up another panel with diagnostics to see at the same time what's happening on the air and on twisted pair. So if you select in the second panel a twisted pair interface and start this.
And it is connected already.
We will see now, maybe clear the telegrams in the upper window. So we can see now that if I switch this off, the frame is encrypted on radio frequency, it's blue. But when it's traveling over the coupler on the twisted pair, it's unencrypted on the way from the coupler to the twisted
It's
pair
great
actuator.
to see it this way now with the RF interface, it being secured up here and unsecured or plain here down there on the twisted pair line.
Yes, there's also the possibility to see this upfront in ETS. without the need to program it.
So.
Similar to the preview of the filter table, you can now also see a preview of the translation of the security proxy. So if you go into the installation again, into the topology, and do a preview filter table on the segment.
So right-click the segment, preview filter table.
Exactly. You there see the second section. So the first section is the preview of the filter table, which group addresses go back and forth through the coupler. And the second section is the security proxy. There you can see that this kind of translation is from a plain telegram in the primary segment, the twisted pair segment, to a secure telegram on the secondary segment, which is the radio frequency segment.
This is very cool.
You can also see the gray shield. The gray shield means that this group address is securely communicated in some parts of your project. If it's blue, it means it's securely communicated all over.
Yeah.
But if there are some parts of your project where this is translated by a security proxy into plain communication, there we have the gray shield as an indication on the group address.
Okay. So I will close out of this. Go back to my slides. What did we see? We can see that now with the security proxy function, one single group address, in our case 2 group addresses, are plain on twisted pair and at the same time secure on radio frequency. And the best of all, ETS manages this for me, for the user. And also, this is probably the most important part, hence the green flags. ETS recommends any changes and any necessary downloads, and I should probably follow these recommendations.
Exactly. So maybe we can see one example where, if you go back to ETS, where you can see what this means, that one configuration on one device has effects on other devices. If, for example, we go on and also want to control this desk lamp from twisted pair, you would simply go to ETS, go to the, in the buildings overview, you can quickly find this push button device in the guest room, and then button 6 is still free. So this one here. And add the desk lamp.
Guest room, desk lamp.
Exactly. So what we have seen is the control of the desk lamp via this multi-device. And now we also control it via the push button device on twisted pair. What does this mean? If you go back to the topology, in order to make this work, what's obvious is that the push button device needs to be reprogrammed. You just added a group address. But what also needs to be reprogrammed? You often forget that also the coupler needs to be reprogrammed because there's a new group address that needs to travel from the twisted pair segment down to the, from the radio frequency segment down to twisted pair and back again. So also the second device is the coupler that needs to be reprogrammed. But why the heck does ETS think that also the devices 13 and 14 need to be reprogrammed?
Yes, I didn't touch these push buttons and actuators.
Yeah, what's happening is that this group address, which was formerly only communicated between the push button device and the actuator, now there's a new device being interested in this group address. It's the coupler, because the coupler needs to forward this on twisted pair.
Okay.
So for the push button device, we said previously he wants to be sure that all of the devices who are interested in this group address have received it through fast ARC on multi. Now there's a new boy in town and wants to play with this group address, and this is the coupler. So there's an additional acknowledged frame necessary for this group address to control the desk lamp. And also for the status back, the controller, the actuator for the desk lamp, sending his status feedback no longer not only to the push button device, but also through the coupler to the twisted pair device. So one change on one device, as a consequence, had changes being necessary on a couple of other devices. ETS, through the programming flags, tells you that this is necessary. So if you see, for example, these dynamic folders on top, there's also the modified devices.
I never use these folders.
You should, and maybe in the future we will make them more prominent in ETS. If you go to the modified devices, you see all of the devices which do not have all of their programming flags set. And the modification that we did just added 4 devices to this list of devices which need to be reprogrammed.
Wow.
So we can do this now, or you believe me, I'm not sure about the time, because there's one thing I still want to show you, and this is the addition of battery-driven radio frequency devices with multi and the SLE extension.
Okay, so we have a new type of device, the RF Multi SLE device.
Exactly. We have here a radio frequency multi, RF multi device, battery-driven with the SLE extension. This means only with this protocol extension, it was possible to do devices like this, which constantly listen to frames on the KNX network for receiving new current temperatures from the room, if it's not measured by the device itself, or to changes of the heating mode. And these kind of devices are listening all of the time with the multi-SLE extension.
Mm-hmm.
When we integrate this into our segment,
so let's say I put this device, this new device, also in the guest room.
Wherever you want, at least in the segment, radio frequency segment 1.
Do I find this in the catalog?
From our special online catalog containing all of the future devices.
Incredible.
This one. Only one remaining.
Now the catalog is empty.
Okay. This has become 1115. It needs to be programmed. Let's hope that this will work.
Did you insert the batteries already?
I did.
Okay.
Again, I have to be patient. Now the programming mode is on.
I'm still on the USB interface, but this should work.
If you're on the twisted pair interface, I personally would switch over to the USB stick for today. Maybe this works in September, but
I'll see what happens. I triggered it already, but this might be right. It takes a long time.
Yeah, it takes too long.
So I would switch to automatic again.
We're still working on some scenarios. It's not ready yet. Otherwise, we would have released it to the market. But the release date in September, this will also work. Okay. But for the time being, if you download an RF device, use the USB stick.
Yeah. I guess then there will also be more than one device in the catalog.
And there will be devices in the real online catalog. Okay. This took too long for the device, so I need to reactivate the programming mode again. So maybe the device is as impatient as I am.
I can understand that you're impatient. But
so some Jeopardy music?
Yeah. This worked.
Okay, now we also have integrated this SLE device into our installation.
But I see it's still unsecure.
Doesn't matter.
Okay, we accept this for today.
Yeah, as we're impatient, we're not reprogramming it again. But we want to control it now. And for this, we could use our black radio frequency device, which is ready, because we're still talking about interworking issues.
Indeed. Yeah.
One thing maybe is you haven't reprogrammed this device so far. If you go to the diagnostics again,
Yeah.
that device that luckily you did not reprogram would still try to send messages controlling the ceiling lamp
Yes, right.
in unencrypted ready. So if you push the button on this,
So I press the ceiling light on and off.
yeah, and we see that this is no longer working.
Indeed.
Why? We encrypted the communication for the ceiling light with the help of the security proxy. So this is no longer working.
So the
Nice.
device can send all as much as it wants. It will not be here.
Yeah.
Okay.
So there's no backdoor for legacy devices
Very good.
being able to control something unencrypted. But let's reprogram this now. We removed from the first button already the control of the ceiling light. So let's use the second one to control something from this SLE device.
Okay, so I see I already have prepared 2 group addresses for this purpose.
Just use them.
So it will tell me that these group addresses will work unsecure.
Exactly. They have been used outside this RF segment in a secure way so far, as we're now linking them to the radio frequency ready device, not being able to do this securely. The security needs to fall back to plain communication. But are we brave enough? Have a look at the preview filter table. This should only happen on the radio frequency segment.
So I see 4 group addresses, but they are still my ceiling and my desk light.
Okay. Should have not been that brave. Let's go on and try to control that radio, this SLE device now with the ready remote control.
Okay.
For this, we need to also add the group addresses to the device.
Indeed.
To the SLE device.
I don't see the object.
You first have to enable this. So if you go to the parameters and the thermostat, no, the room temperature control.
It was here. Yeah.
And there activate the boost functionality for which we have prepared the group addresses.
Okay. So now I see 2 new objects.
Now they're there, so ready to be linked.
This new sidebar comes in really handy with the group addresses.
I also can't wait for the next ETS version to be released.
I think no one can.
So let's release this in the next days.
Let's try.
Okay.
Okay. So I program the thermostat.
Exactly.
If I had more USB interfaces for RF, could I program more devices at once?
Not inside the same segment.
Okay.
It's like with multiple IP interfaces. You can do this in parallel if you're addressing multiple lines.
Yeah. There would be collisions otherwise.
Topology segments, exactly.
But ETS would take care of that for me.
Yeah. Why this took so long at the beginning is because ETS now woke up the SLE device. In contrast to the remote control, which you had to wake up manually, ETS has sent out some wake up frames for the SLE device. Wake up, I want to configure you. So I didn't activate the programming mode again. This is now all controllable by ETS, and it's the proof that these devices are battery driven, energy saving, but still listening on the bus.
This is the 500 millisecond preamble that
Exactly.
it waits, that it checks.
ETS first tried if the device would already be in listening mode.
Yeah.
And after the timeout, okay, this device is not in listening mode. It sent out the wake up frames and waited until the device said that it's ready to be programmed.
I will now also program the remote control.
The remote control.
There I need to press the programming button, which I'm doing now. And now I put the boost function on the right rocker.
I'm not sure if this can be seen. If the boost function is being activated, it should.
So I will press it.
Yeah, go ahead. Michael, did you program all of the devices that ETS told you to reprogram?
I did not.
Not yet. So let's go on and reprogram also the coupler.
This
And
is
why
where
this was necessary, we will see later on.
this is again where it comes in handy to follow ETS suggestions.
So this was a little bit of a spoiler, because the question would be, how could this be that I have an RF ready device being able to communicate with an SLE device? We have learned from the slides from Joost that there's this one break in interoperability, that the existing ready devices do not know how to talk SLE. They do not know how this long preamble wakes up the SLE devices. But here, again, the media coupler comes in. So he's doing all this magic of supporting SLE, segment coupling, security proxy, and he stands in for this ready device and resends the frame in SLE.
So until I programmed also the coupler now, it did not let through the group address. That
Exactly.
simply was the issue.
The radio, the remote control has sent a ready frame that simply was overheard by the SLE device.
Yeah. Okay, but now that I programmed it, I can try. I cannot see it, but hopefully you can see it. I can hear it.
It's going up to 100 now.
The idea of these devices is, of course, not to make too much fuzz, not to have bright lights. You don't want that. And they want to save energy. So when they are in boost mode, you see it and you hear it very quietly.
Yeah, let's trust ETS and have a look in diagnostics, what's happening on the air. So if you clear this, today, currently we have on the second diagnostics a look on the twisted pair side. There's a second radio frequency stick, which allows us to look on the fast communication channels. Remember the slides from Joost, where we have the different frequencies for the different modes of communication, and at the same time have a look at what's happening on SLE. So activate SLE on the second one.
Mm-hmm.
So if you now press the ready button, you will see that this frame was resent by the media coupler also on SLE. So as the remote control, the legacy old remote control could not do this on its own, it was the coupler standing in. And foremost, it was ETS automatically recognizing in the background that we have such a situation and configuring the coupler accordingly. So all you as installers need to do is to watch out if ETS in the background ensured interoperability, resulting in some other devices also needing to be downloaded, like the coupler, which we forgot due to the impatience that we have during the whole presentation. But maybe this helped us to be in time. I'm not sure about the time.
We still have time.
How can this happen? When was the last time you had a project and you did not exceed the time, but you were too fast?
My customer is happy. I exceeded the expectations.
Okay. But maybe we can talk about some more details of this, or if there are any questions in the audience. We have this dedicated Q&A session right afterwards. But we can start it now, or does everybody need to have a break?
We will take questions, but if somebody wants to go and grab a coffee, that's also fine, especially for our remote attendees. But in the meantime, we are here for questions. I guess we can go through the summary.
Let's do the summary. Maybe this raises some questions.
So what we saw in our demonstration and also in the previous slides is KNX is interoperable, and also it stays interoperable. ETS does make sure of that. RF segments, they do offer a lot of new possibilities when I aim to extend an installation. These new media couplers, we saw that it's worth adding those to installations, perhaps even replacing existing couplers, because they offer me new possibilities, new options. And they guarantee the RF interoperability between RF Multi and RF Ready. Again, I think we couldn't stress this more enough and more often. ETS does always automatically set the best possible security. It does also manage the communication modes for RF devices. And this is even more important, it keeps track of which devices need to be programmed. And I think as we saw, and as we also tripped over our own scheme, it pays to follow that recommendation.
Yeah, the bottom line is that all of this complexity that we have seen in the presentation from Joost with the different modes and the different channels and the fast arcs and maybe also this security translation in the proxy, none of this had to be configured by us manually.
Indeed.
It was ETS checking in the background, seeing, oh, there's a ready device wanting to communicate with a slow device. Oh, now the coupler needs to stand in. Or there's a link on a group address being sent out from a multi-device through a multi-coupler to a twisted pair device. So let's make the part which is sent over radio frequency automatically secure. So all that this has been done by ETS, so you don't need to take care. And maybe that's the reason why you might then be finished earlier with your project. And then the timeline says you
and I appreciate that
budget.
Yeah, very well. Okay, so did we now trigger any questions?
In the room, anybody, any particular question to Jan, Michael, or myself on the information we provided this morning? Yeah, could also be that we have been crystal clear, so there's also a possibility. So also, Christoph, if there are any questions from the audience online, then maybe you could also call them out to us.
I could start with questions that I picked up during the break.
Right.
One was the question, why did you show all of these edge cases? It might transport the expression that things are very complicated. And the reason is, if we would have shown the happy path, so create a new project, add RF Multi devices, link the objects and download, we would have been finished in 5 minutes. Because as you have seen, ETS takes care of all this complexity in the background. also in all of the edge cases. So the reason why we showed you all of this is to again and again transport the information that ETS takes care of this. And in case of KNX RF Multi, there's this companion device of ETS. So ETS, together with the new media coupler, they are able to do all this complex configuration. So normally, you would not need to care. We showed you also with the diagnosis information in detail what this means at the end. So if you have a look in the monitor that you know, I have seen Mr. Kessler showing that this hop count 2 means it's a multi-frame, hop count 6 means it's a ready frame, but you do not have to do all this configuration yourself manually. It's ETS taking care of the complexity, and when you just use RF multi devices as you use TP devices, you practically see no difference in ETS. And with the extension of the segment coupler, it's even easier for you now in ETS, working inside the topology, as well as placing of the media coupler. You don't need to have an extra main line in your building. So we have been already earlier finished with our presentation as planned, but the happy path would be a 5-minute presentation.
Yeah, I think it's clear we showed some very specific use cases. An existing installation, we changed even the topology, so we unscrewed devices from the wall, changed the whole setup. You know, we removed the line, we integrated a segment. This is not something you would normally do in what you call the happy path.
Yes, so all of these stumble stones that are there, even with this not finished software and these not finished devices, we could not even work around. They just worked. Change it, we download it. In the background, a lot of might have changed, and we have seen that in the background, suddenly telegrams are no longer ready, now they're multi. Previously, they have been unencrypted, suddenly they're encrypted, and all this happens in the background automatically configured by ETS.
Yeah. But when you start, let's say, fresh in a new project, yeah, you would indeed be done much quicker. And you wouldn't have to do with changing a line into a segment and making something secure back into unsecure and a multi-device acting as a ready device. This is not something you would do in a new setup. I don't really have slides. I just have one slide for questions.
I want to ask you if you can open ETS again.
Yeah.
Because there was a second question. And the second question has something to do with security, but it's equally true for the radio frequency communication. In order for ETS to understand who is communicating with whom, what are the capabilities of the sender, what are the capabilities of the receiver, can I activate security, can I use multi, which fast X do I have to set as ETS, not as installer. In order to know this, ETS must know all of the communication partners in the installation. This is specifically true for visualization tools, which in the past simply connected to the twisted pair. They used to communicate with the group addresses flying by on the wire without ETS knowing it. And this is different now. For security, the receivers of a secure telegram need to know the list of trusted senders. So a visualization tool cannot simply send a secure telegram without being configured in ETS to be allowed as a trusted sender on this group address. And the same way we have this is in RF with RF Multi. So ETS needs to know that there is a communication partner so that an acknowledge slot is reserved for this. We have seen this with this push button device, which at first only needed to communicate directly with the actuator. But when we added this group address in twisted pair, there was another communication partner stepping in, and this was the coupler. So the same frame then needed to be acknowledged by two recipients. And in order to do this in ETS, there's a concept which is replacing the currently known dummy devices. So in order to do this group address assignment to visualization tools right in the past, you placed dummy devices with dummy objects and did dummy associations to these dummy objects with their different dummy sizes. This helped in creating the filter tables correctly for the couplers. In the future, this will be needed to be known as trusted sender, and therefore we extended this concept. So if I go to the topology, do I need to press the keypad? It's not, doesn't work. Do I need to use the mouse? Okay. I need to take the mouse. I can't work with this keypad. We have the concept of bus interfaces. And bus interfaces, obviously I cannot also work with the mouse. So it's an end user problem, not an ETS one. We see on the very bottom, there where you are standing currently, Michael?
Yeah.
Here, exactly. We see this bus interface. And this is the successor to the dummy devices. Instead of having to link group addresses to the right dummy object, a bus interface is modeled in the product data of the devices. So visualization tool developers model that their tools are communicating over an interface. IP routers model these additional tunneling addresses that they have as interfaces for ETS. And then you can assign any group address without being of the same type to this interface. So it looks like an object, it behaves like an object, drag and drop, but you can simply mix all of the group addresses regardless of their length, of their data type, to this interface. And what's happening is that now ETS knows, hey, this group address needs to be known outside the RF segment. Hey, there's this one individual address, 0.0.1. This is going to send probably secured telegrams on these group addresses. So this concept needs to be known. And this was the question during the break. The tool which will then later on connect with this individual address to this interface needs to know all of the keys of the group addresses. And that's why we have in the properties of an interface the button export interface information. So in the future, these secure enabled visualization tools will need to import a key ring from ETS with all of the keys which are allowed to be sent on this individual address, and then it will be decoded and accepted by the secure devices.
Does this work with maybe 10,000 group addresses? Sorry. That's a great feature. Does this work with some thousand group addresses may
Yes.
one customer have?
Yes.
And will be their mode if I add a new group address in my system, that will be automatically added there in this list?
Not yet. This is what we're working on, to have something like you have a middle group in this list, and whenever you add an additional group address to this middle group, it will automatically then be updated here. So to make this more convenient. The reason is that the alternative solution to configure this in the past, and it was a really dirty solution, was manual filter table entries, or having the pass-through couplers flag on the group address. These were concepts from the past that do no longer match with the requirements we have in modern installations with security and multi. That's why this new concept of interfaces needs to be promoted, and we're working on making this even more comfortable.
So that is great for visualization devices, logging devices, something like that.
Exactly. And this is, you see here, the guest room radiator group addresses. These are the group addresses that we had used on the SLE device for the boost, start and stop, and the boost status. And they are linked here so that from the beginning, it was known in the installation that these group addresses need to go through the coupler. Otherwise, the device would not have had a communication partner. In the past, it was totally fine to have only one association, the group address only associated to one object, because the device would have sent out this group address frame from the object to whomever is interested. And who was interested was not known to ETS. With the security extensions or the radio frequency extensions, it's necessary for ETS to know who is the recipient and to know the properties of the recipient to configure the stuff correctly. This is the concept of bus interfaces that will, in the long run, replace the dummy devices, but it's necessary to configure this in the installation. And if you think in security concepts, it's totally understandable. If security should prevent that a hacker comes along with his notebook, connects to the free cable and sends the frame switching on and off the heating, then it's exactly the same thing if it would not be a hacker notebook, but a visualization tool that after the installation has been configured completely, the installer with the ETS project is gone, then the visualization tool comes along and wants to control everything. It doesn't matter if it's the tool or the hacker. That's why the visualization tool needs to be known at the point in time the project is being configured. At least the fact that there will be something like a visualization tool connecting to this bus interface, whatever tool this, what software this will be at the end. But there will be something communicating on this group address to the system. And then it's clear which group addresses need to travel which path through the topology and so on.
Okay, that's great. We have seen today that there are plenty of generations of RF. And as I understand, everything is compatible with each other, which is great in KNX also because also 20-year-old devices will work with brand new devices. But what is doing that magic? Is it only ETS or is it some kind of hardware?
It's the new coupler. So it's ETS understanding the situation and programming the coupler to, at runtime, solve the problem. So ETS detects the different communication problems and uses the new coupler to solve these.
This coupler, if this coupler do many of the magic, maybe we should know how is the name of it or when it can be ordered, because that is a clue here between the different generations. And maybe in September when it will coming out, I don't know how that coupler will be named.
It's a system specification that is valid for all RF Multi capable couplers. So any coupler being capable of doing RF Multi media coupling will need the support for all this magic. The magic behind is not proprietary, it's KNX system standards.
So multi is the keyword we have to be care about the coupler.
If you're searching for a media coupler,
in future projects.
Yes, correct. If you're searching for a media coupler, check out in the datasheet that it's RF Multi capable. This implicitly says that all the magic is supported.
I guess this is also maybe a good moment to remind us of the Kahoot, right? Because this particular media coupler is one of those prizes that can be won.
Yeah, but could be any other media coupler supporting multi-coupling. And then there was a question from online.
Yeah, there was a question from Matthias from Germany, and he's asking, do you expect more RF diagnostic to come? Because he knows that from other systems, there might be installation issues, probably you need a retransmitter or not. Yeah. And he's asking, can ETS also help in these cases in future?
Okay, yeah, so diagnostic features are written in the specifications. They are introduced and included already, and we are working currently on extending the diagnostic features also in ETS. So the user of ETS will have more functionality, more options for diagnostic. Does that answer the question? So we will be, you have to ask Matthias, yeah.
We
So
can
we'll
be
be
more
extending,
specific,
we will be
but-
extending the features in ETS, but all of that is already specified in the specification, KNX specification.
Yeah, what's necessary in the devices to support this diagnosis functionality. This is part of the specification. Like for all media couplers supporting multi, they need to support also this magic. This means that all devices like this actuator or this push button, if they say they support multi, they need to support also the KNX system specification for this diagnostics. And what we will do, I'm not sure. I always looked at this clock and this is 20 minutes too fast. That's why I thought did not have time. But if we have time now, maybe, and no more question, we can go deeper into this.
In the meantime, yeah.
So in order to do all this magic by ETS, ETS needs to understand the communication paths. So ETS needs to know that this push button device will communicate with that actuator and later on with that media coupler. We have seen this as part of the presentation. So all this information that is known by ETS about the communication path, that I have this push button device and that actuator, and maybe here I have a media coupler, and ETS knew that this device will communicate, send a frame to this actuator. This actuator will send a frame back with the status to this push button device, but also the frame needs to go over the media coupler. And I didn't know if we also connected the status. In that case, it would also be that back. So these communication paths are known by ETS. ETS needs to calculate the fast ACK frames. For security, it needs to configure the trusted senders. And this information will be used for diagnostics to say, okay, then let's look how good is the signal strength in the communication between this device and that device. And how good is the signal strength in the communication between that device and that device. There might be a fourth device which might not be in the reception range of this device, but as long as there are no group addresses linked, it doesn't matter. So ETS will make use of this linking information that it has and the communication paths and communication directions to, in this list where you see the group addresses, the channels, and the parameters of the device, you will then have also a signal strength tab where all of the communication partners are listed. So on that device, you would see the media coupler and the actuator. And then you could measure the signal strength between the communication partners. And if you think of a rather huge web, you might have numerous communication paths. But what's interesting is not all of them at once, but looking at each application, each functionality, in order to switch on this light, these paths need to be okay. So ETS will concentrate on this and measure the communication between the relevant devices. So this will also be part of ETS, not ready yet, so we couldn't show it, but thank you for Matthias. From an installer's point of view, it's necessary to have this information and to be sure that devices are able to communicate with each other.
There are some few more questions. I put two of them always together. RF coupler, how do we know it is compatible with an RF device? You just mentioned something about that. Probably you could repeat that. And will ETS6 also support KNX RF Multi?
So the second question first. ETS5 will not support KNX RF Multi. This is one of those features that are supported from ETS6 onwards. The first question, a media coupler, yeah, an RF multimedia coupler, and this will be, let's say, the search term or the description of such a device that will support this functionality.
Thank you. And then one more question to the RF guys, which is, can you have more than one domain in the same system?
Yes, and you should. Like I earlier said, if you have a large installation, it's better to have independent media couplers opening up independent domains instead of trying to have only one media coupler and use repeaters to reach devices which are too far away. So if I have a floor plan with multiple rooms, and I have a green cable, maybe going only that way, and I have RF devices in all extremes, and I have problems with these devices to communicate because they're too far away. Or I have problems if I place one media coupler here and I cannot reach a device, storeroom, another wall, device here, and I would have problems going over the floor through these many walls to this device. If this would be a problem, then it's always the better option to place a second media coupler, which would then open an independent second domain instead of trying to place here a repeater, which would then consume more airtime, more congestion of the domain address, and so on. So it's always favorable if you have the green cable somewhere. That's why also the segment coupler is important, because segment coupling allows you to use any position on the green cable to place the media coupler. It's always better to place multiple media couplers, opening up multiple independent domains instead of trying to use repeaters. In that case that I've just drawn here, if this communication would be broken, it would be possible to communicate between this device and this media coupler in domain A. Then the frame would travel on the green cable to that other media coupler and would be sent out in domain B to this device. And the analogy to Wi-Fi I also mentioned earlier, there it's also better to have an Ethernet backbone and multiple access points instead of having only one access points and repeaters. You always get better signal quality, better experience overall, more telegram loss.
Thank you. So now a question to Joost. Joost, you mentioned KNX IoT over Thread. So there is a question. Is there a library available to develop a gateway or bridge to integrate a KNX TP installation with KNX over Thread devices?
Yeah, for the time being, there is a KNX IoT open stack available, but only for end devices. There is not yet as part of this open source stack, not yet for the router functionality, a corresponding open stack. This might come later, but for the time being, we concentrate on making the specifications. And for the end devices, there is a open stack which is already available via GitLab.
But I suppose there will be gateways available from manufacturers, or?
Yes, like I tried to explain in my presentation, some manufacturers might have a dedicated device, but I think most manufacturers who most of the time also provide traditional KNX, I would say, not IoT KNX. They will possibly extend their existing KNX Net IP devices with a possibility to also route towards this IPv6 segment.
Thank you. So that's an expert one. Is the OPC export adjusted for ETS? I know that several systems use the OPC export to learn about how group addresses are used within the project. And is it a good idea to still use the OPC export, or do you have other opportunities?
For KNX IoT, you mean, or for?
No, that was a general question, I guess, from people doing visualization systems or stuff like that.
Okay.
Trying to get
the OPC export does support security. Or
the group addresses which are communicated securely and the data point types,
Yeah,
they
they
are
are
part of the OPC export. But OPC export is legacy because we need much more information, context information about the project that cannot be integrated in this OPC export. That's why we have currently other means like the project export, keyring export, group address export, but the IoT working group is working on a semantically standard export that will then replace the OPC export in the future, which not only has this group address and data point types, but also the so-called DPA, the additional semantic information from the project.
Thank you. That sounds good. And then another RF question. I don't really get it, but probably you do. Can we filter the RF signals using the media coupler, or can we filter just the group addresses filter table? Probably it's asking about the physical routing and the group address routing. I would expect that for physical addresses automatically also a routing table is created, allowing only physical communication between devices on one side or the other.
Yeah, this is one of those things that ETS manages for the user. Maybe I'm misunderstanding the question. I'm not sure.
And for both point-to-point and group communication, security is available, as we have learned today. So I hope this answers the questions.
Maybe if you refer to physically addressed, so individually addressed group addresses, these new generation of couplers, not only the RF multimedia couplers, but also line couplers or IP routers supporting the security proxy functionality, they have, in order to be able to isolate the subnetwork, also this functionality that ETS has enabled automatically. So it's not possible to inject plain individually addressed telegrams from the subnetwork, for example, from radio frequency to the twisted pair. So this protection and filtering and proxying is not only done on group addressed frames, on multicast frames, but also for broadcast and individual frames in order to protect that somebody tries to inject your installation. And what ETS, this is what you mentioned, also does automatically. So it drills holes into this firewall whenever it's needed to communicate to other devices behind it, for the time being that the configuration is being done, and afterwards closes it down again.
Mm-hmm.
So the last one is a large one. I just read it out, and probably you can. I don't know if you can answer it immediately. It's specifically asking for compatibility between devices. Are RF devices from different manufacturers compatible? Let's say Jung ENET KNX F40 radio transmitter working with ISE KNX RF Multi TP media coupler and Theben Luxor Living D1S RF mini dimming actuator, or Theben Luxor Living RF1 RF coupler with the ISE KNX RF Multi radiator thermostat. Well,
so kudos for reading this question.
Well done. Yeah.
It doesn't include Icelandic volcanoes, but similar.
When well, of course I don't know these devices by heart, but if they are implementing KNX RF, RF ready, RF multi, then they are compatible. Of course, when, I don't know, for young ENET, KNX F40, I would guess this is some kind of gateway between the proprietary ENET system and KNX, I would guess. So I would guess this still to be RF ready. I think most of the devices in the market are RF ready these days. So I think I think most of them should be compatible. Yes.
It's the DNA of the association to guarantee this interworking. So as long as these devices are certified, have the KNX logo, we will guarantee interworking.
Regarding the last sentence, is the KNX RF Multi radiator thermistor from ISE compatible with current couplers? I learned, or I understood, that current couplers on the market are ready couplers, and a ready coupler is not compatible with a multi-device, though a multi-coupler is compatible with a ready device. Isn't it that way?
Correct. It's
Okay.
a kind of backwards compatibility. So the new coupler will support all others, but like you said, an older coupler, an RF ready coupler, cannot support, especially not a slow, low energy device.
Yeah. They are, as always, for certain edge cases, certain edge case solutions. But the easiest way, and the information you should take home, is if you're using the latest version of the coupler, you don't have to worry about edge cases.